Welcome to the first video of the STPM Physics. I will start with the first chapter in the first term, which the first term will cover the mechanics and the thermodynamics. Now you can see I write down these two references here. If you are the STPM student, I will recommend you use the second reference for this STPM student because this is based on the STPM syllabus. The first one is for the general physics. You can use until your uh, first year of university. Of course, if you take the related discipline. Let's go to the definition of a physics. Physics is a fundamental of a nature, which the relation interaction between the natural properties. When we talk about physics as a subject, this is a study of a fundamental of nature. Our goal is to understand how the universe works. So, what physics will cover is a thing. They are the fundamental exist in the nature. For example, the things like motion, heat, electromagnetism, quantum mechanics, uh, nuclear, quark, wave. This all the thing is covered in physics, which of course there's still a lot I haven't listed down here, but this should give you a brief idea what we do, what we learn in the physics course. Now let's talk about the physical quantities. Physical quantities is a thing that can be measured. For example, we have a pen here, and I can use a ruler to measure this pen. Let's say I get 50 cm. So you can see this is represented by the numerical value and the unit. The numerical value is the T here and the unit is a cm. And here the base quantity is a physical properties that can be direct measured. For example, here the length, we measure the length of a pen. This is the consider the base quantity. We directly get the measurement from the ruler. For example, the thing like time is also the base quantity. We can directly get from the stopwatch, this kind of thing. Now, the things like speed, right, equals to the x over t, and this x is a distance. Distance is a length, and divided by the time t, and we know they have a SI unit of a meter per second, right? Now this is not a base quantity. The speed is not a base quantity because you can see it formed by two base quantity. One is the distance, actually the length, and another one is the time. This is what we call the derived quantity. I will explain more in the next video. The thing that are formed mm, two formed by two or more base quantity is what we call the derived quantities. Now, the physical dimension is just the properties related with the quantities that we use for the classification and to differentiation. To differentiate, clearly we know this is this length and the time is not the same thing. So there are two different physical dimension. Now let's talk about unit. Unit is a standard for the measurement of a quantity. So the keyword here is the standard. And units is used to define what exactly the measurement to be compared with. And the base unit is the unit for the physical properties that can be measure directly. For example, the last time we have a pen and we measure using the ruler. Mm, let's say this the length of a ruler is twice the length of a pen. So we can say that the length of the pen equals to half of the ruler, so to say. So in this case, you can see actually we can make this ruler as a unit, right? But the problem about this kind of the unit is that we can have a different type of a ruler. Some ruler they have a 50 cm and some ruler they have a 30 cm. Some ruler is a 1 meter. So here you can see if we just cram this is a ruler, the, we have the different kind of a ruler which make the thing inconsistent. This is very confusing. To resolve this kind of a problem, we introduce the thing what we call the international standard of a unit. This is a SI unit. So now this is the most important worldwide system, and the word is come from the French. So as I said, we need to have a standardized all across the international so that everyone can understand what we are talking about. Exactly how many is 1 meter. This is a very important thing actually. This slide show the table for this base quantity, unit, and the definition. Actually, not much to explain on this thing because this is just definition we human define. But actually, this all definition is basically based on something that are constant. Those things everyone can agree on. For example, the meter here is based on the length of a path traveled by the light in a vacuum per 299792758. So actually this is based on the speed of light in a vacuum. So this is what we call the universal constant. From this, everyone can agree on the unit we define because this is the same all across the whole universe. Now, actually, some definition is not that suitable to introduce at this time. For example, the kilogram. I mean, you have an idea about the kilogram, but we come with this new definition here. They actually requires you to have knowledge for the second and the third sem to understand what mean by this statement. So for now, I don't think this is suitable to introduce and explain all these things. For now, you just read through. I think you also have a brief idea from a daily life for this unit show here. Now, this is a unit prefix. What actually this is just a multiplication of a division by an individual power of a 10. Here you can see this is what we call the scientific notation. Now we replace this scientific notation with a given symbol. For example, let's say 2 kg is actually means you can see this K is a kilo. This is a kilogram and we have a 10 to the power of 3. So that means this is a 2 multiplied with a 10 to the power of 3 grams. Right? This is just some definition. The notation is to easy our life, so you can read through. You will account this thing over and over again when we in later of this lecture. So in the next video, I'm going to explain on the derived quantities. See you then.